because the shift with Erdogan, you also have to realize that it's not really about him. There's a global dynamic that is gripping the planet. I'll give you one example of this, Japan. I'll tell you, if Japan shifts away from the British monarchy and the plans of the transatlantic financial oligarchy, whatever you want to call it, if Japan shifts, that'll almost be more tectonic than Turkey. Turkey is very crucial geographically. But right now, I don't, maybe people have heard this, but Abe, the Prime Minister of Japan, who's also not been on the great side of everything. Remember, he was the one that went to the Yasukuni Shrine, is that how it's pronounced? Which is to honor the heroes of World War II. Well, who were the heroes of World War II? The fascists, right? Or
that's who he was honoring, the fascists.
Yeah, so he's not been on the right side as well. But he just invited Putin to come to Japan, but specifically to come to his hometown. So this is a kind of a potential shift. And concerning next month, at the beginning of the month is the meeting in Vladivostok, which is the Far East Economic Development Plan. Okay, Abe will be there. Clearly, of course, Russia and China. Park, the president of Korea. Remember, they just put these THAAD missile systems, the terminal high altitude, whatever they're called, missiles, which is both Russia and China know has nothing to do with North Korea. This is part of the global missile defense shield so that Russia and China won't be able to launch a second strike after we launch the first strike. We being NATO, I guess, Canada, you guys aren't too far away from what we're doing, so. If both Korea and Japan begin to shift as well, this becomes tectonic, right? So the Vladivostok meeting followed immediately by the G20 meeting, then as Paul mentioned, the UN General Assembly, and then after the UN General Assembly finishes at the end of September, you have the BRICS Heads of State meeting in India, and Modi will be hosting that in India. So this, and you know, contrary to the BRICS are dead or whatever, right? That it is not dead because it's not, the BRICS isn't the Brazil, Russia, India, China, South Africa. The BRICS is a concept that is part of this reshaping of what is a world that isn't ruled by an imperial ideology. Now, in the middle of this, we're also going to be having the performance of Mozart's Requiem to the 15th anniversary of September 11th. On the 9th, it's going to be the Bronx. The 10th is, I think the 10th is Manhattan. The 11th is in Brooklyn, but it's actually going to be at the cathedral. It's a Catholic church, or you know, the Catholic cathedral, and I believe the bishop will actually be doing the mass. So this is it's a big deal, and we're going to be inviting. We're actually doing a huge outreach to the Muslim community as well. Well, in all communities, but I think that would be very important to have this sense that this 9/11 wasn't just an attack. You know, it was an attack on everybody, you know, including the Islamic faith. And then the 12th will be in Morristown, Pennsylvania. So we're going to have 4 performances of Mozart's Requiem, and this has a kind of way to intervene into the situation, which may not be political per se, but it's so human and so profound that it can have the kind of effect, like, you know, when the Berlin Wall came down, people, it wasn't initially, what was that stupid band, Stryper or something like that. It was Beethoven's Ninth Symphony that they were singing in the streets of Germany, right? So it can have that kind of quality to it. So, so I just think, you know, that's where we're at. It's quite amazing. And I would say this, that it's not we have to realize that it's a new idea that is taking over. And there's going to be people who had old bad ideas under the old system that are either going to change their mind, or maybe they change their mind momentarily, maybe they don't change their mind, maybe they get kicked out once they, you know. So I don't think we can really get into all this question about the various personalities that are associated, because it's not just being determined by the personalities per se. I'm not saying that it's not any bearing on the situation, but it's a new idea that's sweeping the planet. So now I want to just discuss somewhat.
So what's the message? I didn't get. What's the message?
What am I going to do here?
No, message of ceremony
of Mozart's well, it's to honor the victims of 9/11, and in fact, we're going to have the families on the event in September 12th in Morristown, Pennsylvania. We're going to have a number of the families. We're also going to have a lot. I believe the one at the cathedral is going to have 100 firemen that are coming to participate. So, but this is the 15th anniversary of September 11th, and there's really not been anything that's addressed this. And now we have 28 pages that's been released. We also have the Chilcott Commission, as people know. Now the Chilcott Commission laid it out. Tony Blair and lied and launched a war of aggression. Right, so. But
you invited Muslim community, so is it unification?
Well, it's just to make the point that everybody was targeted with this. You know, we're just making, because there's a lot to say that it was the Muslims behind 9/11. Well, actually, no, it was.
Everybody was addicted.
Yeah. So.
Can I add one?
Yeah.
Just one very quick thing to this is that, and I'm always struck by this, especially in Canada. I don't know. Mostly it's because of the antipathy, I think, in Canadians, and also the political system in Canada renders us impotent as far as foreign policy goes. And the harder you try, the more impotent it seems things go. But this process that is already happening, being led by Putin and Xi Jinping, but also being led by the changes now in the idea of starting this process of development, of these development corridors, of the infrastructure. They have to be spread, and they do take on a life of their own, but I know for myself, we have to ask ourselves, are we just observers in all of this ourselves here? Are we observers, or are we participants in that process as well, in spreading it? And it doesn't mean you have to join a committee. It doesn't mean you have to, organize a rally. It means that you're talking. It means that you're spreading these ideas, telling people about the good news, and that's really, really important as part of that. Because we can't just sit back on our laurels and say, Putin's got it. We have large problems in Canada, huge problems here. Canada is stepping up its role, and it is showing itself to be the administrative military backbone of this whole operation on behest of the British Empire and the financial empire that is the British. So we here, need to help them. So I'll get off.
So now the other thing I just want to, just as a point of reflection, last year at the United Nations General Assembly, September 28th, Putin gave his speech. And this is where he called for a coalition like we had in World War II to defeat the Nazis. He called for a similar coalition, of course, this time to defeat terrorism. Now, of course, I think it was within days you had a major terrorist bombing attack in Ankara that killed 100-some people. A few weeks after that, you had the Metro jet from Sharm el-Sheikh with Russian tourists on board, 224 people dead. So clearly that coalition was not formed, and then of course just think of the last year from Paris to Brussels to Nice to, and then not to mention Sudan, Pakistan, Yemen, you know, all the places that we just sort of oftentimes in the West we just sort of chalk it up, well that's just how it's just accepted or something. So anyway, the fact that not only has he called for that kind of coalition, but the other part of what both Russia and China know is you can't have security just by killing the bad guys. You've got to have the economic development. And I think the fact that this north-south corridor, which was the meeting right before Putin and Erdogan met, was in Azerbaijan, this is going to cut right up through the Chechen zone of, you know, the Chechnya,
Up the gut.
right up the gut of that terrorist potential. You know, really, as Paul mentioned, if Turkey isn't just Turkey, the Turkic people is the whole swath over to the Uyghur part of Western China, through Kazakhstan, Turkmenistan, etc. That whole region from Turkey, Azerbaijan, the Caspian Sea, and beyond. That is the great game operation. So if you take away Chechnya, if you take away Central Asia, all they're really going to have left is Libya and Afghanistan, and given that that's Obama's responsibility, it'll look a little obvious that you know, that's the only place the terrorists can go, is the places run by Obama and company. But the point is, the key to the security question is the economic development. And what I'd like to do is throw out at least one sense or some of my reflections on Mr. LaRouche's economics, which are fundamental scientific breakthroughs that I think even in our own organization are not fully realized. But I guarantee you people at the Russian Academy of Sciences have dove into Mr. LaRouche's work. People in the Chinese scientific community have dove into Mr. LaRouche's work. And so what I would like to give is at least just kind of a general, very general statement, because the nature of what we have to do has to be efficient, for lack of a better. We can't just say we're just going to develop. I don't know if people, some of you all were down in Seattle when Dr. Hussein gave his presentation, but he went through the energy requirements of the Silk Road, but made it very clear, this idea that you can just have wind and solar, which is below break-even level or break-even potential. Those are not options right now. Now, let's say you say, okay, well, the fourth generation reactors, some of these advanced reactors are good. Well, how far out do you go? How many of them do you build? How many of them are you building while at the same time you recognize that the next upshift that we have to make, which would be towards fusion, right? What's your sense of when fusion could come online? What happens when fusion comes online? You know, would the modern grid even handle the capabilities that would be represented by that? I heard a presentation by guys who did these superconductive cables, which are like the power lines they have now will not be able to handle the kind of flow that would be needed.
They can barely handle what we have.
Right. So these superconductive cables, so you're going to have to upgrade that. So there's a kind of a pace of development where it has to be thought through from a physical, scientific standpoint. And what I would like to go through, just as it'll be brief, is the question of how the universe itself operates towards optimal conditions, okay? Or as is, I will use this term, others say, well, it's more specific than that, but it's what's known as the principle of least action. Okay, so I want to start out with one idea because Mr. LaRouche has identified the central role of Nicholas of Cusa as really the founder of modern science. Now that might seem paradoxical because he was a cardinal in the Catholic faith. He's actually somewhat a controversial figure in the Catholic Church even to this day. He was the guy that held the, well, under the yet to be completed dome in Florence, held the discussions about the reunification of the Eastern and Western churches after the, well, it was during the whole Byzantium wars and so on and so forth. But anyway, I won't go too far into what Cusa, who he was, but he, in one of his seminal works, refers in Didacta Ignorantia, as it's called, of learned ignorance, he discusses, he says that all things in the universe strive to do the greatest that they can with whatever limitations that they have. Now, if you fast forward a couple hundred years, so Nicholas of Cusa was 1401 to, I think he died in 1460, 1460 or something, 1464 maybe. So he was really not just the founder of modern science in that sense, but he was really the godfather of the Italian Renaissance. Anyway, there's more to that story. But if you fast forward to the late 1600s, you have this figure, Wilhelm Gottfried Leibniz. And Leibniz stated it almost exactly the same way in one of his seminal works, which is Specimum Dynamicum, which he developed the whole concept of dynamics. Okay, but same thing. This idea, I don't have the quotes in front of me. If I were more prepared, I would have brought them, but I did not. But the same idea that in the universe, the nature of existence is that they strive to do the most with the least. Now, the way that Cusa developed it was, he called it the maximum minimum. Now, I just want to throw out as a, if we took this as our minimum, you know, what is the maximum, what is the shape that would represent the maximum? You know, we could make different shapes. We could have a square. We could have a triangle. The maximum area in between. And forgive my little tape things. It just was too long to do Omega 1, so I sort of cinched it up. But just to ask, do people think that this has as much area as that? No.
No, that has more.
Okay. So then, does anybody have a hypothesis that maybe doesn't know the answer already about what would be the shape?
A circle would probably be your maximum.
Why do you say that?
Just because of what I know physically, in my own work and everyday.
All right, let's think of it in another form. What if you could have a, oh, go ahead.
I know in bubbles and balloons, you've got, when it's high pressure, it presses out evenly in all directions, and that's why we've got the circle.
Yep. So in a three-dimensional case, if you had some given surface area, but you wanted to maximize the volume inside, the greatest expression of that would be a sphere. People can kind of think it through, like what else, and you of course could work it out, you go through mathematics, and you can realize that that is. Now,
Can I say something?
Yeah.
Like what you're trying to do there with that string
yeah,
or cord is to answer your question of what's the maximum area you can get with it, there's some principle of action involved in there. Isn't that like before you get to the area you want to create, you create that through action. So is this what is more important, or it's together with the whole process? Is that important? That,
Like what kind of action?
yeah, what kind of action is going to create what you are asking us?
I don't
to
know.
create?
One thing you could do is if I had a high-powered blower and I blew right in the middle of it, all these edges would all flare out. It
Yeah.
probably would give you a circle, but
Yeah.
I don't know if that's what you mean by action. But
Well, it's human action, that's
Yeah.
involved in this, which is what? Creativity?
Well, let me, because I think this question
Maybe
of
I had too
creativity.
much coffee.
Well, I actually think it is important to identify what do we mean by creativity. I'll tell you, having gone to art school, the idea of creativity is frankly just bizarre.
Isn't that where you create something out of nothing? Isn't that creativity? Something
Yeah,
out of nothing.
but shouldn't we ask what kind of creativity could also ensure future creativity? In other words, like I often use this as an example, and maybe it's a bit extreme or whatever, but all forms of cultural practice are not equal, and frankly, some of them, by the very fact that the performance of them does not allow their future performance, means they were failed cultural concepts. I'll give you one example of this. This is I have not read the study. Somebody who I know did. I'm taking their word for this. Whether it's exactly true or not, you get the point anyway. Okay, but the story goes that I believe it was in Angola, somewhere in the 90s. The World Health Organization was trying to figure out what was going on with an outbreak. I think it was Marburg fever, or Marburg virus, or whatever it is. But whatever sickness this was, it has an extremely high kill ratio. So if you're infected with it, 90% of the people die. Now, for the transmission of disease, what turns things into epidemics where it's able to spread widely is when the carrier isn't affected by the symptoms and is able to go about living their life infecting other people. And so somewhere around there's an optimal infection or kill ratio, or however you describe it, which is around 30% as far as I understand. Okay, so that means 30% of the people die, but 60% live to go infect everybody else. So here the World Health Organization is watching village after village die, and they can't figure it out. Like, why this should not be happening like this way because of this high kill ratio, right? So what they found out is that there was a tradition where there was a bathing of the body that then afterwards people would take a small amount, and as a concept of immortality they would have that. So now, okay, again, I don't know.
100% transmission.
Huh?
100% transmission.
Yeah, right,
Yeah.
right. So now, again,
That's a good example. Yeah.
okay,
I think it's
whether
really-
it's true or not, let's just say it's point is that as a cultural practice will not allow for the future cultural practice.
Why they did not do it before?
Huh?
No,
They
it's
should
pretty
have
clear.
been
I don't know.
extinct a long time ago.
Yeah, maybe so, I don't know, whatever the
That
point is.
tradition doesn't keep them alive.
We could have the same discussion about other elements of culture. If you have culture that does not challenge your people to think, and if you have, you take a Beethoven versus Britney Spears, right? How long is it before the idea content of Britney Spears eventually makes that civilization go extinct? And people don't
Pretty
reach
fast.
it.
Wouldn't any paradigm do that?
What's that?
Because if there is any paradigm at all, you have to fit things into that paradigm. So I see a paradigm, like
You mean like a?
restrictive, not against
Well-
creative.
Well, I guess what we're getting to is the question of, well, what is creative?
Yeah.
And I would say that creativity has a directionality to it. And what you get in art school is the idea that creativity is just self-expression, you know. It's just do whatever you want, you know, splatter paint on a canvas. And because it was you expressing yourself, it was somehow creative, right? But does that really do anything to further the cause of creativity? Does it actually convey an idea content that helps elevate so that a society can make future scientific breakthroughs, future...
In the art example, what they do is they circumvent teaching you skill by telling you that you can paint whatever.
Right.
And it's going to be the development of skill. Even though the skill, you're learning one skill which is restrictive, you nonetheless have something to build upon. Build a second skill and a third one. Until gradually you get to the long way around to being able to just splatter paint on a canvas. Apparently Picasso was a highly skilled illustrator.
Oh yeah, he was quite well
People who
trained.
followed him, I don't think.
I think with the example of Britney Spears, it's a different senses. It's a visual against the Beethoven when you actually listen. So it's
Different elements.
Yeah.
of your brain working.
Oh yeah.
Okay, that's okay. But regards this, like we said, creativity, when you don't build it, so you don't have a movement to perfection, I think it's mostly done to dumb people, to take them away from cultural experience, from actually seeing the world and seeing the beauty, and that's part of the process that takes place in different places, but part of it is interpretation of creativity from, you can do it right now, here we go, just do it, great Mark, go.
I challenge you to listen to the words of a Britney Spears song.
That's not it, I don't listen, I use my visuals.
Well, you know what, a lot of, anyways, this is an aside, but a lot of music, the lyrics, they go into your pre-conscious.
Oh,
You may
yeah.
not be conscious of
Yeah.
the lyrics, but they're in there.
Yeah.
But anyways.
There's something completely different happening there.
Yeah.
Yeah.
But
Now, I want to just I want to throw out one idea here, which is that because I think there's a coherence between how the mind works and the way that the universe actually functions according to this idea of optimizing its effect or its principle of least action. Okay, so I'm not getting. Okay, so as you can see, we have the beach over here.
What?
This is the beach.
Oh,
as you can
beach.
see.
Okay.
And of course, this is the
Squiggles.
ocean.
This is the water.
Ocean. Now, what's going on here?
Bubbles?
Okay, so yes, we have our person who is also. Okay, so now you're over here, right? And you have to save your drowning friend. Now, what would be the quickest way to get to your drowning friend?
Helicopter?
Besides that.
Well, if you were Jesus, you could just run right there, right? But once you hit here, since you're not Jesus, you all of a sudden have to factor into the reality that swimming is much slower than running on the beach.
There is another factor if you have a cell phone. So it's you fighting between being famous and actually post that video. Or actually risk your life. You have a good friend.
Doing a selfie
So
while
you
you're
see, it's
running.
not fighting having one friend saved or millions of followers on your channel.
All right, well, we're going to outlaw the idea that you would run away or...
No cell phones.
So either you could run straight to the beach and then swim the rest of the way. You could run straight to the
Shortest.
You mean it's not a circle?
Huh?
It's gotta be a circle.
He has to swim this way.
he's got to swim somewhere in between.
No, no, no.
It's the direction of the current.
Swim aiming to the right of the person.
Oh, because of the current?
Yeah.
Well, let's assume that there's no current, it's just, he's just magically floating out there all.
But there's no current, then, yeah.
The bigger thing is that you're taking into account that once you enter this domain,
You have more resistance.
you have a slower time
Yes.
to go through the medium
Ah.
versus a much quicker time through the medium, okay? So now, I don't know the exact, whether it's this way, you know, and then slightly curved. If it were, if this was jello instead of just water, so imagine trying to swim through jello, you might actually want to run to the minimal time that you'd have to spend in the jello because it's going to be so hard to fight through. But whatever the density of this medium versus the density of this medium, if this was a beam of light, it would follow that same optimal path. So in other words, your decision process of trying to get from there to there, based on the density of this versus the density of this, if you think of your optimal approach, light will follow your direction, or will follow your pathway.
Or conversely, you could find the optimal approach by shooting the light.
Assuming you can swim.
Light basically is gonna take the least time.
Exactly,
The least time.
exactly.
Based also on the density of each one.
Yeah, exactly. So now, I'm using this as a general example that the human mind actually operates like light in that sense. That the universe the processes within the universe do that automatically, if you will. But if we think that way, in the right way, we will do that too. We will take that optimal approach. So I want to ask another question here. If I have this here, we'll say point A and point B. If the idea is that I want to find, if I had if I had this ball here, and I wanted to get this ball to here, assuming that it is straight down, if I let this ball go, the quickest path to get to there will be a straight line, right? Now, what if I moved C, or what if I moved B over here? And I said, by what means would I get from A to B in the quickest time?
With that ball?
With this ball, and all I can do is drop it. But I could put it on
On a straight edge?
Or on a
I
rail.
could take this thing, and I could put the ball right here, and it could just roll right to it. I could draw a crazy roller coaster type thing, and the ball could roll down here, and loop around and roll there.
Oh, yeah. I don't know if Bob's
Oh, is this
No, it is. It's
They're
just-
not permanent markers.
No,
a-
they're
No,
not.
no.
We use this, okay.
Otherwise, people find out our secrets.
Better erase them again.
This is dangerous
They'll start
material.
rolling balls all over the place.
This material can change the world. Understanding this is very.
Okay, now, I'll be honest. If you don't know the answer, you're probably not gonna guess it.
Can you take them?
Huh? Nope.
Be a curve to it.
Why do you say a curve?
Well, on the curve, it would accelerate the velocity, which means it would arrive at that point more quickly than a straight line. Because of.
Because it would have this initial acceleration,
Yes.
you're saying? So
Yes.
some sort of a curve
Yes.
would get you there. Would it be a circle? If you could like put a
Draw a full circle around that?
circle, you know, I'll just try to do my best.
My guess is yes.
You need a tool to connect from point A to point B.
Yeah.
And that tool could be that piece of string there. You put a point A and point B, and there you would have your.
You're saying that if I take this,
That's what I think.
Say between the two.
Would that not give you what you need?
would it be this one, or would it be this one?
You have to let it hang somehow, from point A to point B.
Pull this guy off.
Or you take a saw and just cut it in the middle.
Cut the whiteboard.
Yeah. And join those two pieces.
Join the two pieces. Okay, we don't rule out anything here.
This Russian arena.
So you're saying take this point here
Yeah.
Then you
and figure out,
That's it. That's the curve you would need.
that's wrong.
Oh darn.
My guess is within a circle, within a sphere.
Okay,
If it's a circle, you just
It's
have to ask a question if the two right angles
No, but the
intersect
question is
with the
the answer.
axis,
uh-huh.
or if it's gonna be just a part of the circle. You see what I mean? Is that like gonna be a quarter of the circle, or is it gonna be less?
Well, how about this, just because it's useful to kind of think of ideas. But I'm just gonna give you the answer.
Okay. Fast forward.
Okay, so this right here, from this point to this point, this curve represents the quickest path there.
That's quarters. Like that.
This is actually what is called a cycloid. This is what you would see if you had a bicycle tire that was this high, and this was the reflector on that bottom of that bicycle tire, and as the tire rolled across, this would be, and if you watched it at night, it would appear to just keep making this form over and over if you watched a bicycle going.
Oh, it's on the spoke?
Yeah.
Yeah.
A point on the tire.
On the tire.
On the rim.
Point
watch
at
it
the tire
on the
is
rim.
rotating.
Yeah.
So I'll show you with this handy dandy little thing here. This was all assembled last night, so right here, see how this, watch how the end of that green, oops. It's indeed.
You have to have
So you
something.
would have there.
Yeah, just put that right there, so I'll try to do my best. Get the basic point.
Yeah.
Yeah.
Very good.
Incredible. Yeah.
Okay, now, there is a amazing phenomena of this.
That was called a cycloid?
Well, yeah, a cycloid. Okay. So actually, Dr. Christie, do you mind holding that right there? We're going to scoot that back about there. So. drop, this is going to be kind of loud, but I'm going to drop this one, and we'll see which one makes it there quicker.
Whoop,
Yep.
Yeah.
it came off the track.
Can you do that again? I missed it.
Yeah.
Well, I mean,
Yeah.
All right, let's try it again. Let's see if I can get them a little bit more. 1, 2, 3.
which went first?
I just missed it.
Yeah.
The circle's quicker.
You try your best to release.
It's like a third.
Yeah.
Do it again, do it
Yeah,
again.
One more time.
yeah.
Okay, will somebody come?
Watch the center point, don't watch the balls, watch the center point where they
Here,
intersect.
hang on. I'm gonna get this on video and up close. Okay, hang on.
It'll be fine. The only thing is that I want to make sure that this one is.
At the center.
Put a mark on the
Okay, ready? 1, 2, 3.
Circle. I saw it up close. I pulled it right in.
So obviously that's.
Slow motion. See it in slow motion.
See it in slow motion.
All right, now clearly if I drop this one from this height and this one from this height, which one's going to get there first?
Both at the same time.
The small, the closer one.
Yeah.
Same?
Yeah. Yeah, about the same. About the same, yeah.
Oh.
So it's 50% more efficient, is that correct?
Let's go to the part because there's obviously friction issues.
Straight line.
But
Wow.
you know, it
Wow.
doesn't matter where they
Doesn't
are at.
matter.
Doesn't matter.
How can that be?
Really?
I want a
That's-
cycloid.
Yeah,
How can that be?
You should
This
go
is better
and
than Slinky.
go and build this and make those.
I want a cycloid.
Now, I'm only going to just say it, and then, you know, it's not like it's going to, oh, I see, or you ruined it for me, I wanted to make the discovery on my own. But what it has to do with
forever, Dave.
is the fact that on a circle, clearly if I were to drop a ball from this height versus rolling it down there, it's obviously going to take much longer. Even though this ball will accelerate, the way the acceleration works is in 1 unit. In 1 unit of time it goes 1 distance. In the next unit, 2 units of time it goes 4. In 3 units of time it goes 9. 4 units of time, 16, and it's a squared relationship per unit of time. That's how the acceleration works. And there is a phenomena of the circle, which is kind of a, you could say a sort of a physical Pythagorean theorem, that even though from here it's a shorter distance down, you know, like if I were to just drop this, it's a shorter distance than it is here, but because it's mediated by a slant, it takes longer to get down here than it would if it just dropped straight down to the ground, right? So this will take less time than this one. And then again, this will take less time than rolling along that one. However, if I took all of these and rolled them at the same time, let them go at the same time, they would all arrive at the bottom at the same time.
Cool.
And you could figure it out why that works. But that's what this takes advantage of.
You're saying if you roll them all along the circle part, or you're saying if you roll
Like
them?
if I had these 2 balls and I dropped them at the same time, 1, 2, 3, even though this one is clearly closer to the ground, but because it's at a tilt, it's going to take a slower amount of time. But these two will arrive at the same time. These two will arrive at the same time.
In relation to the angle,
Yeah.
the slope.
Yeah.
Because the one at the top, when it arrives at the level of that, the one in the middle, it already has some velocity in it due to the acceleration. That will not work in vacuum. Not vacuum, sorry, with no gravity.
True.
There has to be gravity present for it to work.
Because the one at the top, you drop it, it starts accelerating right away. By the time it reaches this point here, when it goes down here, it's already moving with a high velocity compared to this one. This one is starting from zero.
Right.
Yeah.
While this one is starting to accelerate, this one is also accelerating.
More acceleration.
It's
Yes.
the same story, this and this one here. So the end result, you go down at the same time.
Now,
Right.
there is a, this is a very crude attempt at this, and it doesn't quite work, but just to get the basic idea, actually. Pass it down there.
I have one more question. So are you saying that the ones going straight down will end up at the same time and going this way will end up at the same time?
Yep,
Both ways?
yep.
Okay.
All three of those points, if I drop them, if I release the balls all at the same time, they will all arrive at the bottom at the same time.
Either going this or that?
Like,
All going
like even though this one will kind of slowly roll down versus this one, which is just, you know,
But what about
the slowly rolling
Which
down.
one will do?
Which way?
Will
Going
hit it.
straight down?
No, what about the other ones? Is that the same?
Same, yeah, this one and this one
Oh, yeah.
will both hit at the same time.
Oh,
You should understand, how do you go like this? And I don't understand.
Well, if you had the rail, seeing the
It's the
rail.
same
You
way
are
as the
setting
rail.
up rail.
Yeah, the rail.
Yeah, so like, let's say we had this rail right here. If I drop this ball and it rolls down there, and I drop this ball and it rolls down there, if I had two of these rails set up, and I released this one, and this one, and this one all at the same time, they would all hit the bottom at the same time.
all of them, whether they're going down or that? Okay.
And what you're dealing with this thing, the cycloid, is that as each one of these, as this is rolling along, each one of this point here, there's a tangent point that goes to the bottom of the circle. And that, if you release the ball rolling down that way, would hit the bottom. And as it keeps going, again, from there to the bottom point, we're doing the same thing that that's doing. So this is, I know it's kind of confusing, but it's okay, we're good. So as it rolls along, it's kind of upside down. If I flipped it around, from this point here to the bottom of this, a ball rolling along there will hit the bottom. My words are failing.
Slower, faster, same speed.
Well, what this is doing is at every one of these tangent points, it's going to the bottom at the same time. And so this effectively equalizes all of the tangents, because that's what it is. It's just It's a collection of canyons.
Yes, yeah.
So again, this is, I'm giving you like a, you know, two-minute version here.
So it's the optimal
If you put a rubber
pathway
band
of any point along that sequence.
Given the parameter of what we've decided,
Yeah.
which is the
Yeah,
question
yeah.
of
Yeah, yeah.
how do you utilize, because what's the other, if I gave this a velocity in this direction, what's the optimal path to get to this point? If we were playing
What you're saying,
beanbags, right, and we had a thing on the floor, you would have to figure out what's the parabola that optimizes.
So how much energy is required to be applied in that
Right,
direction?
because clearly if you throw it too hard,
Yeah,
it's gonna go.
it's gonna go too far.
It's gonna go too far, and if you don't throw it hard enough, it's just gonna.
So it's the same curve.
No, this is just confusing because it looks like
The same- the
this
same
is a
shape.
parabola.
It's part of the parabola.
Yeah.
The three of them.
So it's a different curve. Yeah.
Parabola is a cut of a conic section.
Yeah.
It's the cut that is parallel to the cone. Come down.
That's, yeah.
There you go, yeah.
From the side,
Yeah.
it would look like that.
What are the dotted lines there? Okay, so you cut the cone parallel and then you.
Yeah, if I had a cone
Yeah.
and I cut it parallel to this,
Yeah.
if I looked at it over from the side, it would appear to be
Like a curve.
sliced.
Gets us,
So then something like this represents
The
a
same
cone.
that you cut it this way.
You cut it
Yeah,
on an
yeah.
angle.
Okay.
What does that plane look like?
That would, if you, but it has to be, cut has to be somewhere between bisecting the circumference of the line. I don't know if this is where to create a graph. Otherwise, you've got an ellipse. If you cut it anywhere where it intersects that around this edge,
Yeah.
no, this is not.
it goes down to
It's
the
parallel. Parallel?
yeah, on both sides, yes, cut through.
What type of knowledge you
So,
This is a,
This would be physics. Usually studying the way that things work.
stuff like this.
actually, I'm not going to try it. There's a good way of showing
I suppose.
the conic sections with my fingers in the way. So there's the circle. This is an ellipse.
oh, yeah, right.
And then eventually the ellipse breaks and
Yeah.
becomes the parabola.
Right.
And the point of that breaking is when this side of the parabola is parallel to the wall.
If you have a flashlight, you know, when we were camping, you can see it all the time with the flashlight. You know, if you're walking with the flashlight straight down, it's a circle, and then as you move the flashlight up, the whole thing changes, right? Into these
Shifts
shapes.
into an ellipse. This is an ellipse to all of you. It's a circle when I have it this way, and when I tilt it,
Yeah.
it's an ellipse.
So, just to cut to the chase, are you suggesting that our minds are affected by the same law, or the same drive in terms of optimizing, like in the universe, it's expression of the universe, that we try to optimize for at least, for most of the least. Are you saying that our minds are the same, are affected by the same?
Yeah, I would pose to you that any paradox that you deal with or any question of economic development, you're trying to think in that way. You're trying to do the most with the least. And when you, like, let's take the example of fracking. Okay? Think of how much work product is put into the extraction of the fracking operations. How many semi-trucks are out in the middle of North Dakota? How many tires are, you know, popping on these semi-trucks? How many gallons of gas are wasted to go get the semi-truck full of the fracking liquid? How much wasted, you know, all the fracking mud, this toxic mud that they pump down to smash up the, how much work do you have to put in relative to what you actually get out? We're approaching a point where there's a break even, where what you put in isn't even what you get out, and that's called attrition. And once you hit attrition in an economic process, you're dead.
You're missing one very important point, that on the top of that you're polluting water supply,
Yeah, exactly.
which makes it for the long term
More negative.
not even like absolutely negative.
Yes.
In the long term.
Yes.
There is no even point of trying to realize.
But
It's
I'm
not-
just-
in the time, if you look at this second, or like at this minute or at this day, it might make some sense. The longer
Right.
you look, the worse it is.
The same thing goes if we said, let's move forward on the 4th generation reactors. Let's say, well, let's mass produce them, and for a time being, we are going to want to do that. But there's also going to come a time being where we realize that if we do too much of that, when we know that we're going to have fusion coming online, we're going to have to now start making the preparations for that. So you're going to have to make a forecast about how much activity you want to put into a lower domain, knowing that you have to have the higher domain coming into it. So when you're dealing with an economic process, you have to think about this question of optimal or least action, and even more, because you're not dealing with just simply one discrete example. You're dealing with a constant process of evolution that always has to be moving upwards and upwards in terms of a higher energy flux density.
Then you bring an interesting point of responsibility and how the stock market or how the CEOs are acting based on short-term benefit.
Those
Very badly. Very badly.
Okay, so I just realized that this is not going to work. Where did I? Oh, my fingers are too big. I can't get this in there. What we're going to do is we're just going to do a makeshift operation. Okay, that's about. Now, this right here is again my shoddily made.
Do you want a piece of tape?
Huh?
Tape?
It's fine. I'm just gonna kind of. It's just sort of badly made, so you just get the basic point. Now, remember those tangents that we were discussing? This is a reflection of all of those different tangents. Okay. And what this is half of the cycloid that we created. And this is what Huygens developed, because one thing that happens with this is even as this pendulum swings along that curve, at the bottom, no matter, even if it slows down by friction, just like this ball, if we had a metronome, it would always pass that point at the same time. Remember, because of what we did before, where I had one ball up here and they would both reach the bottom at the same point? So that means that this ball will always hit the bottom at the same interval. So what Huygens figures out, and this is probably middle of the 1600s, is that you could apply a clock which would have this, and even if it slowed down, it would always, and yes, the period would be the same. So that's what you see here is this is the clock. This is just one part of the.
So that's how the pendulum clock was.
Yeah. And he, of course, that's extremely useful for a ship. And so he actually just set it up that it could just kind of, as long as it stayed level, even if it rocked back and forth, it didn't matter because it would
What? The ship would be where?
Well, it would keep time no matter what. It wouldn't get
It still keeps the same.
it wouldn't get disturbed. The pendulum in a normal clock wouldn't be disturbed by a kind of
Rocking motion
Oh,
ship.
by the ship.
yeah. So he had it, I believe, in some kind of water contraption. So even as the ship tilted, it would always remain level.
Right.
But this, meanwhile, would. There's more that he goes into on that, but.
Was that for navigation purposes? Just strictly for time it took to go a certain distance? That's all? The clock was used for? or was
I
it-
don't, you know, it was just to have a good clock that
Yeah.
worked. Yeah.
Well,
Right.
the clock,
Or
would,
determining
It's
latitude,
it's also just
longitude?
more
Longitude.
accurate.
Yeah, latitude and longitude, degrees, minutes, seconds.
A combination of the
Yeah.
time and
Yeah.
taking longitude,
Yeah,
latitude, seconds.
take sight,
Yeah, yeah.
sighting your star.
They can then pinpoint where they're at.
Yeah, exactly.
These two will determine the peak.
Yeah.
So you're gonna have, if you make it short, you get a shorter period, if you make it long, you get a longer period. So that's why, yeah, you can make that, it has nothing to do with the friction.
Well, even in this one though, with the friction, even if it's,
Even then, it's the same because here it depends only on the acceleration due to gravity and the length of the earth. It's actually the square root of everything.
Okay.
All of this actually is coming as a result of the gravity is 1 over r squared. If it was 1 over r or 1 over r cubed, all of this would become zero.
probably the universe itself wouldn't be able to. Okay, so, let me just leave this last part as a question for next time.
What?
Another question for you to think about.
Oh, I wanted to keep going.
I know, but it's just, if we had a bit more time, we could probably have
You've already blew my mind.
Yeah, that's a start. That's the
Now
right
he's in-
direction.
Does that mean you got an empty head? No?
We emptied it, now we're filling it.
yeah, right,
Just
right.
lots of wind.
It's blown.
okay, so,
Need to-
because I didn't really get a chance to develop it, the idea of this curve, there's an idea that it's discussed around so-called evolutes and involutes, meaning the curve that evolves from an original curve, but then if you have this curve and you sort of involve it, you could develop the other curve, right? Now the cycloid has the unique characteristic such that the curve that evolves from the original curve is actually the other curve. Okay, so this, what people are seeing is basically like this, okay? And what they're seeing is
That goes from this one.
they're basically seeing, what you're seeing with all those little points there is you're seeing this, the one at the bottom, this green ball is all of these P's, okay?
Yeah.
And then the Q is all these points up here that stretch out to the Q, okay? So this has a unique
In a straight line.
property, yeah, that all of the tangents, the evolved curve that comes from the original curve is actually the same curve, but that's the only curve that does that. For example, take the evolute, or the curve that evolves to become the ellipse is what Huygens calls this an asteroid, not an asteroid, but an asteroid. So each one of these tangent points would unfold from the original curve to give you this ellipse. These are just other examples of that same concept. Now on the back, you can maybe see it a little bit better. So in other words, this curve here, called the semi-cubic parabola, when unfolded, gives you this curve, which is the parabola. So in other words, if I have a ball and I throw it up in the air, this is what is a parabola. And the involute of the parabola is this curve called the semi-cubic parabola. Now this one has a very interesting phenomena that if I rolled a ball down this and it kept rolling down, even though it would be accelerating as it went, if you could watch it from the side, it would appear that it did not actually descend at an acceleration. It would just appear. So in other words, as it went faster and faster over this way, if you could like roll along with it with a video camera, it would appear to just be falling without acceleration.
You mean if you looked at it straight on as it falls down this way?
Yeah. So like if it starts here,
Just watch it fall.
and it, yeah, even though it's going to start accelerating, going faster and faster this way.
Right.
If you look at it from the side, it would appear to just be falling. If you could speed up it and going that way,
Oh.
it would appear to just fall
Okay.
without acceleration.
Okay.
That's like the
But
planets.
you
Would that
would
be
get that
planets?
effect if you could look at it this way too.
Yeah,
You look at it this way.
Yeah, there you go. But also, if you look at it
Right.
rolling down the side, it would just appear to just go, even though it's coming faster and faster towards you, it would look like it would just.
So if you have an asteroid coming at you and we're looking at it from the side, from Earth, how do you figure out how fast that thing's going? That's my question.
If you are projecting,
Yeah.
if you are coming down that curve, but if you project it along
Yes.
on the screen on this
Yes,
side,
exactly.
then you're going to see it going down.
Yeah.
Yes.
It would just come down.
Yeah.
Just at a constant.
That's
rate.
right.
Yeah. Yeah. Exactly. Yeah. Okay. Now.
Everybody say yeah.
All right, that brings me to this, and this is where we're going to leave it. This right here is what is called the catenary, okay?
Right.
And so the question about this curve is, do you think that this curve here, even though it's kind of wiggling around, so is this curve the same as this curve?
No.
Or let me ask it this way. Could it be that this right here is simply a magnified version of this little segment right down here?
Yeah, I buy that.
So in other words, if I could continue these up, it would actually, looked at from back a couple blocks away, it would look like this. Okay. So this has quite amazing, if you could kind of just, or Scott, why don't you come grab it down there and see what happens. No, just just grab it in midair. Oh, we're like, but don't lift it up. Just kind of just kind of grab it,
Just grab it at a fixed point.
and it will keep that same.
Maintains, yeah.
Oh, yeah.
So at any, if you grab it anywhere, it just maintains.
I'm
its-
Canadian.
See what the universe is subjecting you to?
Oh, yeah.
Constantly.
So, yeah. Now, what is the
So it replicates itself.
what is the so-called evolution of this curve? In other words, if I took the bottom of the catenary and I unfolded it according to all the tangent lines, what is this line here? And what is this curve here?
These ones here.
Oh, wow.
This, what is this curve?
I would say it was a cycloid. That curve is a cycloid.
What that is, and maybe some other day we can play around with it because we just don't want to take a little bit too much time to develop, is what's called the tractrix.
Oh.
Okay, so if people
Oh.
can follow,
Can you move the stuff out from in front of there?
How do you determine this point here?
it's the entire length of this curve right here.
Okay.
So this this amount from there, that whole line, straightened out. This whole amount of the this whole amount of the curve right there,
And then
This is going to
straighten it out.
comes in after this point, and then there's other.
So what Dr. Hussein asked is how do you develop? If I took this point right there, but I straightened it out, that would be the bottom. Or similarly from this point here,
And the length
straighten
gets shorter
it out.
and shorter.
Yeah.
Gets shorter and shorter, and that's how you
Yeah.
know that.
It's the same as you were doing there, just on this one.
Yeah. So now the one at the bottom is if I followed, if I had if the path that my finger traces out, as this gets dragged, that path is this. And why? We'll leave it for you to figure out for next time. Now, let me just, because there's kind of more to develop around it. Which you kind of have to develop it, you know. In other words, I don't want to just turn it into kind of like, wow, look at that, that's really cool, and this, you know, it is just kind of neat on its own. But I think the point that we at least began with, the idea that all of these processes are knowable, but all of them express in their own way. They're all expressions of what Fuse says, what Leibniz says, is the idea of, you know, optimal least action. You know, it's the idea that you're doing whatever your given parameters are, you're establishing the greatest expression of that. And that human creativity is that we have to make the decisions that similarly optimize, you know, however you want to describe it, that does the most with the least. And the question of human economics becomes much more involved because it's never some static thing. It's always a constant process of development. And you have to see a lot that's going on at the same time, but all of the decisions that you're making along the way have to be governed by this same decision. And frankly, those same decisions are also decisions made in music. That's a whole other question.
Now, let's take the situation where we're developing nuclear energy for the use of, or nuclear for the use of energy. And we're doing it out of the natural gas paradigm. We're going to find a certain amount of energy return on energy invested. That's one of the terms they use. Will that development have one of these patterns? Like, or will it have its own pattern and you have to discover it? Or
You know, I don't really know the answer to that. I will say this, that what is a very interesting thing about the catenary is so let's say I take this tangent point, and then it hits the point of the tractors here. My drawing's not very good. There's a particular, this is the curve here, the catenary. And if I took the tangent at that point right there, so in other words, and when that intersects the tractrix, you have this circle that has a unit of 1. And I know this is just going to sound like a bunch of geometry or whatever, but you create this phenomena that this is this number called E, which shows up in all kinds of...
okay, I've heard of E.
Yeah.
Don't know what is it.
Should be called B for what Leibniz called it. Euler changed it, I think, to E as far as the rumor goes. But anyway, you find this E in these growth processes, even animals and things like that. Why E shows up in gravitation, I don't know. But it's a logarithm. It's sort of a, I don't know, optimal logarithm or something.
Is it a constant though? Is it a constant?
Yeah.
Yeah.
It's a constant,
Yeah.
it's
Yeah.
2.7.
It would have to be, yeah.
It's 2.7.
Ah,
Okay, yeah.
exactly?
Sorry, what did you do here? This is the tractrix
Exactly.
that you,
Do you commit to that?
you're doing this essentially, but
Yeah, like this is just one of those.
one of these.
Yeah,
lines.
one of those, and then it's intersecting the tractrix.
One of these.
I'm using a circle that's based on this as a unit 1.
Okay.
Anyway, this is, you know, whatever. This is what it is, but
Okay.
I'm only raising it because
There is something similar within.
you're going to find that there are growth expressions and things like that it's not like the curves are transferable per se, but the concept that generates the curves will be transferable. And for that, I don't, you know, LaRouche developed his economics concept as the LaRouche-Riemann model. In fact, I have this just for people's, if you took the tractrix and you revolved it around itself, you would create what's called the pseudosphere. And this is Riemann's model of that. Now, I'm not even claiming to know a lot about the pseudosphere or something like that, but what I'm getting at is that what Lin has done with his economics and why he called it the LaRouche-Riemann method is that there's a way where you're exploring principle as it's expressed in its many different forms, given the different parameters that contain it.
For Sherry's benefit, can you repeat what you said in conclusion about Kuza's discovery in this exercise about the least least action?
What about the economics? Or?
In terms of you just summarized this whole exercise in terms of
like I say, again, this is it's. I know we kind of went through a lot, and some of it is sort of just fascinating, just because it's neat physics experiments. But the point is like this idea, you have the drowning friend. Why would your pathway to get your drowning friend be the same pathway that light would take? So in other words, like as we explore these things, each one of the solutions is based on, when you present the sort of the parameters of the solution, you're trying to find the optimal approach, the sort of this idea that the universe expresses to being the greatest it can be within the given parameters it has, or things that are existent within the universe. So the human mind actually accords with that. And
What about Nicholas de Cusa? Did you say something about him?
well, Cusa, I don't remember exactly what I said, but he had this idea of the maximum minimum, and that same concept.
We're kind of saying he was a grandfather of the sciences, and also he kicked off the Renaissance.
Because he developed these kind of thought experiments that, they're really, if you read it, you're kind of like, well, at first you have to kind of realize what he's doing, and then once you realize what he's doing, he's developing these kind of thought experiments to get your mind to see the paradox of what he's laying out. I know that's difficult because I'm just sort of saying that, you don't know what he's saying, you've read, or maybe you have read it or whatever, but
We haven't, but I think it's something we could go through, because I think you would actually really like it.
And so, so anyway, so this, and then as far as what Lynn has done with his economics is, what do you do then when you add more and more moving parts to the thing, if you will? Not that you can really think about human evolution and not just human evolution, but so the evolution of the solar system, the evolution of the universe as a whole. Those are a lot of moving parts, so-called. But each one of those moving parts, for something to exist, or even to participate in something that is an evolutionary process, is always moving in this direction where every step word up is a further maximizing of its potential.
There's a great paper, I think, that illustrates this called Kepler's paper on the snowflake. Which
Oh, yeah.
Last year.
Oh, yeah, that's brilliant. It's also readily understandable for people. It's something you can read and blow your mind without having to really know much about physics and science. What Kepler does in that paper is he explains why there's no two snowflakes that are the same, and why you have a six-sided flake.
Always.
And it's very.
It's not arbitrary.
No, it's not arbitrary, but there is no two snowflakes that are the same.
So why does the snow?
But at the same time, like the physics, like as we learn more, these things are evolving too.
Well, that's the other side of it, is the real, and I didn't really go into all this just for time issues, but it's, this is why you can never, take what Einstein did. There was nothing within the present bounds of what science had known at that time to lead to his discovery, right? And what LaRouche always goes after Bertrand Russell. Why? Is what Bertrand Russell did in mathematics wrong, so-called? I don't know enough about it to say that it's right or something. But what he's doing is he's trying to contain to say that you could essentially mathematize
Yeah, this is what I was
physics,
paradigm.
right?
Anytime
That you
have a
could
paradigm.
what?
But it's physics that develops the mathematics.
Right, yeah.
It's not the mathematics that is somehow waiting out there it's always the physical paradoxes that challenges the mind to make a creative discovery, and then you might write a description about it, which is called a mathematical statement.
Right, which might only fit for a certain, like the law of entropy fits in the.
Right, that's
closed
it's a,
system.
yeah. But
Yeah.
Well, can I just intervene here? There is a difference between a belief system and a paradigm.
Okay.
And the two are very important to differentiate, because what we're referring to when we say paradigm, and what we're talking about with all of this, is that they're part of a system that already exists in nature, and you can prove that to yourself by experimenting and exercising with, like what we did here, and lots of other ways. That is very different from a belief system which is based on cherry picking, which is based on what people believe to be a worldview that's complete, which is actually not complete because it hasn't been tested. It's not scientific.
It's not verifiable.
Well, there's also,
I don't think, though, that there is anything that will not evolve.
No, of course not.
In that sense, they're the same. In that sense, like a paradigm might be very much better than a ridiculous belief system, but in the sense of knowing more and more and more.
But what we're talking about, though, is that, like with Plato, the point is to not have a complete system.
That's
the
right,
point
yeah,
is to
yeah.
get towards, we're ever improving to perfection.
So in
but
that sense, you have to
It's
be able to pick out the
open-ended.
mistakes of Plato
Of
and the mistakes
course.
of
Everything.
Exactly, yeah.
everything.
Yeah, whereas a paradigm, sometimes what you're doing is fitting things in when really.
I asked a
it-
question.
It's sort of it's similar thing.
Yeah. I asked a question in my philosophy of history class, and I was asking kind of an obvious question, but I was asking it also, like, it wasn't understood what I was asking. And I was asking about the context of the exercise. And he said, I'm not talking about the context of the exercise. I'm talking about the context of the context of the context. We're talking about, because what is beyond our minds, right? Does something exist if it's not in our mind, vice versa, right? What we're talking about are things that we can know with our minds and can prove to ourselves in the physical universe. And that there are we can't ignore that there are parallels between the two. And that and if we see that the universe is not arbitrary, our minds are also not arbitrary. So I just challenge you to think about like that in itself. There's no coincidence.
well,
I agree with that part.
Yeah.
And
And that's the context. Yeah. That's the context, right? We're not talking about imposing a paradigm on top of that context. We're saying that that is the context.
What can happen is context can become paradigm. Like, I guess the thing is that it's if you are convinced that, or no, how can I say it? I think I've already said it.
Could I
Just
say
that-
one
just that-
thing,
yeah.
Jerry? Because I think you're saying, if I get you right, you're saying a paradigm is sort of like a system of thought or something?
Yeah, so maybe I need a better definition.
Well, just think of it this way. What is the old paradigm based on? It's based on, oppression and this imperial construct and, everything that's bad, right? But if you move to a new paradigm, it doesn't mean that you're just like changing out all the old rules for new rules. What if the new paradigm is actually based on a process of creativity, which doesn't ever end? Because, like, even if you take what Einstein did, right, there's things that he did that we're still proving them, the whole gravity waves and things like this, but there's also things that he did which allows you to create instrumentation to then see things, so-called, like you see these different, if you've ever looked at the Crab Nebula, you'll see like the X-ray view of the Crab Nebula, the gamma ray view of the Crab Nebula, the ultraviolet view. Well, are you really seeing those things either? No, you're not. You're basically seeing that those sensors are being provided as a visual aid to recognize the kind of things that are going on, but you don't see those. You and I can't see gamma. We can't see ultraviolet. We can't. But what the mind does, what through these instrumentation is you create essentially a mental image that allows you to quote see things. So there's things that we haven't even been exposed to that are going to be paradoxes that are going to demand a further. So the point on somebody like a Russell is if you try to say that it all can be put within a box or something, or there's some logical deductive system of thought that encapsulates it, then you're cutting off the very, the process of generating new ideas can't end, you know. Then you develop a mathematics that tries to describe what your discovery was. So you're always creating new mathematics, if you will, because that's just the language to describe the discovery which originated in the imagination first.
Right, right.
So Russell tried to put the human creativity in a box, and he did so. This is what we're fighting to break out of.
But to fight to break out means that you can't make like you can't make boxes.
Yeah.
That's all I'm saying.
Yeah.
Yes.
You mean to get
boxless paradigm?
Yes.
Yeah.
The new paradigm is boxless.
I want to say something in case anybody else is like me. I tried to read So You Think You Know Economics, and they got to some of this stuff, and it just, you know, to the uninitiated mind, it was just like, I have no idea what's going on.
It's tough. You got to do with some of the experiments.
Yeah. So, I mean, in school they call this scaffolding. You actually build up the layers to get to the point. I want to suggest that maybe reading something like that be the end goal.
Yeah.
And stuff like this be, because also you're isolated. You're reading this thing. It's like, oh my God.
Same with
I'm confused. Thank you. You know, now what do I do? Do I continue reading? Do I put it down and go find, you know, my Archie comics or something?
Well, I tell you though, this reading that, saying what in the hell is Lynn LaRouche talking about, does somewhat then, because sometimes you also, and that's unfortunately the way it'll work tonight is, you don't want to just present these things as things in and of themselves, like, wow, look at this, isn't this cool, this ball hits this, you know, it's kind of like fascinating, but it's something in a larger context.
But we need more of this, and maybe think of reading something like that as the end goal.
Right.
Yeah, I agree. Steps.
Yeah.
Going to school to neuroscience is not a good idea either. I know in schools.
Thanks, Dave.
Yay! Learning science in school is okay.
Oh, I know that.
I mean, they're not going to, I don't know if they'll teach you this.
Oh, okay.
But at least you're learning something, right?
Yeah. I know they don't buy only about history in schools, they buy about many different topics too.
Yeah, because what happens is the teacher brings what the teacher knows. Right? The teacher's not been taught the right things, and he's going to teach you. Right?
So I'm gonna, we're not gonna
science, but
Too late.
Do you lie about science theory in school?
there's problems there too, but at least they have to be practical. When your television works, at least you got something that keeps it grounded.
It's a battle.
Reading and I can't remember the drugs.
I know you got science. I remember grade 9.
You ever feel a rock that size that
I can tell you, it's definitely not uranium. It's not even lead.
Elementary school, they're both like